Hi, students. Welcome back to second semester, and it's very interesting semester. So today I want us to focus on something very important here. And the first lab we're going to do for the second semester is called chemical kinetics. So we're generally going to focus on three labs this semester. And the part of chemical kinetics has got three parts. So there's chemical kinetics with respect to how the concentrations are affected with respect to time. Then the second part of the chemical kinetics lab we're going to focus on is temperature and how it is affected with respect to time. Hi students, talk of securing the future of academia at the University of Zambia. Join the Pomboroka movement. Remember, Narapomboroka, Warapomboroka, Warapomboroka, Ishinani Pomboroka. So what are you supposed to understand in this experiment and what are you supposed to focus on? So under the chemical kinetics experiment, we're going to be given two reactants, okay? We're going to be given the first reactant, which is going to be potassium iodide. Then the second part of the reaction that we're going to be given, or the second reagent that is going to be given, is hydrogen sulfate. So what are we supposed to do? You're supposed to understand that when you get back to your lab manual, you've been given something very important here, which is a table. So this table has got solution A, and this table has got solution B. And then the other thing you're supposed to understand from here is that the volumes of these solutions have been given. For solution A, when you get back to your table, there's 5 mUs, there's 4.5 mUs, then there's 4. Then the other reactant which has been given, which is the hydrogen sulfate, has also been given. The concentrations, the volumes have also been given. We have 5 mUs there, 5 mUs there, 5 mUs there, meaning that the volume is just constant. So generally, what are we supposed to do? We've been asked to find out something very important here. We've been taught to find out the moles of the potassium iodide, and we've also been taught to find out the concentrations of this potassium iodide after dilution. So what are we doing here? We are going to get a volume of solution A. Okay, so the first volume here has been given as 5 mUs. And then to this solution A, we're going to add some distilled water. And the volume of this distilled water at 5 mUs of solution A is going to be 0. So meaning that we're not going to dilute anything there. But the volumes of solution B are still going to maintain. So there's a solution A here, and then solution B, which we're going to mix together. Then we're going to vary the concentrations of solution A by putting distilled water there. Okay? So now, looking at this explanation I've given here, how can we get the volumes of A? How can we get the concentrations of the potassium iodide? And how can we get the moles of this potassium iodide? So when you get back to your lab manual, a certain important work has been given there. We've been given that the mass of the potassium iodide as 2.14 grams. All right? The other thing which has been given there is the molar mass of the potassium iodide as 214 grams per mole. So this is what has been given there. The first thing we're going to do is find out what are the moles of this potassium iodide. So this becomes number of moles. How do we find that? This is mass over the molar mass. A mass of 214 grams divide a mass of 2.14 grams divide 214 grams per mole. And then you're going to get the moles as 0.01 moles. So this 0.01 moles are the moles of the potassium iodide that you're going to find. Now, we've been told that these are per liter. So if this is per liter, how can you find out the exact concentrations? So this is very easy. You know that concentration is given by number of moles over the volume. The volume is 1 liter. So what you're going to get there is 0.01 mole per liter as the concentrations of the potassium iodide. This is before the dilution. Okay? So remember, what we've just found here is the initial concentration of the potassium iodide before the dilution. So now we want to find out what would be the moles and the concentrations of the very potassium iodide at 5 mUs, at 4.5 mUs, and also at 4 mUs. So we come back here. We're saying that concentration is given by number of moles over the volume. The concentration that is already existing there is 0.1 moles. okay, of the potassium iodide. We want to find out the number of moles at what volume? At 5 cubic centimeters, okay, or at 5 mils. So meaning that we can't still keep the 5 mils, we have to convert that 5 mils into liters. And you know that you multiply that 5 mils by 5 times 10 to the power negative 3. So when you multiply 0.01 by 5 times 10 to the power negative 3, we're getting the moles of 5 times 10 to the power negative 5 moles of potassium iodide in 5 mils. So this is how you get the number of moles of solution A. That is the potassium iodide at 5 mils. Then the other thing, when you go back to your table, you've been asked to find out what is the exact concentration of this potassium iodide. Quite very easy as well. We know the initial concentration is 0.01. And at 5 times 10 to the power negative 3, meaning that 5 mils here, we're having this volume. Then the other thing that we need to understand from here is that we'll now begin to vary the concentrations of this solution A. Meaning that 5, okay, at solution A at 5, we have 5 mils as the initial volume. Then we have the concentration as such. Then how about volume 2 on the other side? What are we going to have? What we need to understand is that we are only having 5 here, meaning that we've not diluted anything. The volume is only 0. All right? So the only thing you're going to have here is the first concentration of the potassium iodide at the first part of the video here, of the first part of the table here, you're just going to have 0.01 mole. Then the second part of it, you need to understand that we've diluted. And how many mils of the distilled water have we added? We've added 0.5 mils. Against what mils of solution A? We're having 4.5. Meaning when you come back here to find out C2, okay, the concentration after dilution, the concentration of C1 still remains at 0.01. Then we're using a volume of 4.5. And when you come and find out the final volume here, we are saying that this is 0.5 plus 4.5, which is going to give us a total volume of 5 mils. That becomes the volume 2. So when you get that, you still find out the value of the concentration after dilution. So the first part of this video, I've only focused much more on how you're supposed to get the moles and how you're supposed to get the concentration of the potassium iodide. So make sure that you get it right, and also make sure that you go through the lab manual to exactly understand how you're supposed to fill that table.
So, in the iodine clock reaction, we are now trying to see what is really happening in our chemical reaction. So, in our chemical reaction, as outlined in the lab manual, we are able to see 4 equations. So, if we look at these equations, we have potassium iodide. This potassium iodide is able to react with hydrogen sulfate. With the hydrogen sulfate, it is producing the iodide ion. So our iodide ion is able to react with the iodate that is in excess in our reaction, and this is now producing iodine. So this iodine now, in the reaction, we still have the hydrogen sulfate. Hydrogen sulfate is a reducing agent, and it is capable of reducing the iodine back into the iodide ion. So this will delay the development of the blue-black color iodine complex that is formed with the starch. So after this is produced, we find that as the reaction goes on, the hydrogen sulfate will be depleted. Once it is depleted, we find that there is now accumulation of the iodine. So this accumulated iodine will react with a starch that is already in solution B, and thereby forming a dark blue iodine starch complex. And that is how we are able to monitor our chemical kinetics in this iodine clock reaction.
All right, now we want to dive into the lab session and introduce the technicalities of procedure. So the first thing we're going to do with the first sample, which is sample A.
All right. So the first procedure, as we can see, we have sample A in this burette. So what we're going to do, looking at what we have, in the initial state, we're supposed to get 5 mils of sample A, and then we're supposed to dilute. But in this case, since we already have 5, and we're supposed to have a final volume of 5, we're not going to dilute the first 5 mils we're going to get of A. But in the second one, we have, well, we're supposed to get 4.5 mils of sample A. After getting 4.5 mils of sample A, we're supposed to add 0.5 mils of distilled water so that we have a final volume of 5. So what we're going to do, using this burette, we're going to get 4.5 mils. So if we get 4.5, to go all the way okay. So we have 4.5 mils of sample A in the test tube. So to 4.5, we're now adding 0.5 mils of distilled water to make it 5 mils. So just a bit. Okay. So in total, we have distilled water of 0.5 and 4.5 mils of sample A, making 5 mils of solution A.
Perfect. So we've collected the first part. Then remember that the reaction with the second reactant, which is reactant B, and this is the hydrogen sulfate. So now the sample B has a fixed volume of 5 mUs. Sample B has a fixed volume of 5 mUs. Now, what are we supposed to consider here? Something we're supposed to consider here is that we've already filled in here. So we're only collecting 5 mils of sample B, which we're going to mix with the samples of A, which has already been collected. But remember that sample A has been diluted. So we're getting how many mils? 5 mils, starting from 0. We're getting 5 mils, and there we are. Okay, so the 5 mils has already been collected. Second thing, the 5 mils of sample B has been collected. And remember, the first part was also collected, which is sample A. And what we're supposed to do here is mix them.
Yes.
So he has the timer here. Mr. Shola has a timer. And what we have here is sample B. And what we have here is the diluted sample of A. Remember, we added, or he added 4.5 mils of A, then plus 0.5 mils of distilled water. And what we're simply going to do here is going to mix them. And once I mix them, it's going to start the timer. Once the solution of A touches the solution of B, it's going to start the time. And once it sees any color change, it's going to stop it. Isn't it, Mr. Chor?
Exactly.
Exactly. So I'm going to mix this. Now keep mixing that until we see any color change.
You need to stand it, you're not.
Exactly. So there's a color change here. And when you remember in the introduction, you mentioned something regarding the color change which has happened here.
Exactly. So as we know, we have formed a complex between starch and iodine after the reaction at the end. And our time that we have, as you could see, this is 12 seconds.
Exactly. So this is how you carry out the experiment. And remember, we've been given a table we're supposed to fill in. From 4.5 mils of A, we're going to move into 4 mils of A. Remember, we're going to again add distilled water, come and mix with sample B, and then we're going to repeat the exact procedure for until we fill in the entire table. So this is how you conduct the lab session, and we wish you a wonderful time throughout the course of the entire lab session.
Indeed.
Hi students, talk of securing the future of academia at the University of Zambia. Join the Pomboroka movement. Remember, Nara Pomboroka, Wara Pomboroka, Twara Pomboroka, Ishinani Pomboroka.